Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we will discuss about question number 43, NEET Physics paper 2015. Students, let us solve question number 43. If energy E, velocity V, and time capital T are chosen as the fundamental quantities, the dimensional formula for surface tension will be. So that means we have to write surface tension. Suppose the formula or symbol I'm using for surface tension is S. Then I have to find the formula for surface tension or dimension of surface tension in terms of this E, V and T I have to write. Suppose that we have to use application of dimensional analysis, which says that if I have a quantity X which depends on so many quantities, suppose say A, B and C, and we don't know the power of A, B, C, so we'll write that this is small a, small b and small c. Then we'll just solve the equation. Dimensionally we have to compare and find the value of these powers A, B, C and put this here to get the expression for X. So likewise the surface tension S here, suppose that it is proportional to these three factors given: the energy, the velocity and the time, and the power I'll take A, B and C. Then this is equal to some constant e to the power A, V to the power B and T to the power C. This dimensional formula for surface tension will be how much? As it is clear that this K value, so dimension of this must be equal to dimension of this, including this one, and this must be a dimensional constant. It must be any number, so therefore it has to be neglected because any number has no dimension. So finally I have the equation the dimension of surface tension must be equal to the dimension of e to the power A, V to the power B and T to the power C. I have to solve this in terms of dimensions and then find the power A, B and C. We know that surface tension is force per unit length. So force is M L T to the power minus 2 in terms of dimension divided by L. This L cancels. So it is M T to the power minus 2, or I'll write M to the power 1, L to the power 0 and T to the power minus 2. This is the dimension of S, and that is equal to energy, dimension of energy. The dimension of energy dimension is M L square T to the power minus 2. So I write here M L square T to the power minus 2, the power is A. V dimension is L T minus 1, the power is B. And T dimension is T and the power is C. So this is the dimension of these terms. Now this equals to, that implies M to the power 1 here, L to the power 0 and T to the power minus 2 becomes equal to this one. I'll separate the M power. M is only here and the power is A, so it is M raised to the power A. L square and the power is A here, so it is L to the power 2A. L to the power 2A. Okay, now t to the power minus 2a, here L to the power b, t to the power minus b, and t to the power c here. So this is the dimension. Now this implies m to the power 1 here, L to the power 0 here, t to the power minus 2, that is equal to m is there only 1, m to the power a, L is here and there, so L to the power 2a plus b, because base is m, so power will add up, so 2a plus b, t to the power minus 2a minus b and c plus c. Now the dimension of this is equal to the dimension of this, that means this will be equal to this only when the power of m here is 1, so a must be 1. If m to the power 1 is there, then these two will be equal. So similarly L to the power 0 is there, so if I have this power equal to 0, then I will say that this and this is matching. Similarly, if this whole thing becomes minus 2, then I will say that this is equal to this. So that means I have to equate the powers to solve. So from here, m raised to 1 from left side and m raised to power a from right side must equal. That implies here a equals to 1. Comparing these two, a must be 1. Similarly, L to the power 0 and 2a plus b must be equal. L to the power 0 is equal to L to the power 2a plus b. That implies that 2a plus b must be 0. This is suppose equation number 2. This is my equation number 1. Similarly, t to the power minus 2 must be equal to this. So t to the power minus 2 must be equal to t to the power minus 2a minus b plus c. You can see that left side t to the power minus 2, right side t to the power minus 2a minus b plus c. If I equate these two, then from here this implies that this is minus 2a minus b plus c, this value must be equal to minus 2. This implies that this is suppose equation number 3. So I have got 3 equations. First equation says a value is 1. A value is 1. If I put the a value 1 in equation 2, then b will be minus 2. Put a equals to 1 in equation 2. This gives me 2 into 1 plus b equals to 0, or from here b equals to minus 2. So a I have already got 1, b I have got minus 2. These two values are put here in equation 3. So put a equals to 1 and b equals to minus 2 in equation 3. If I put those values, then what I will get? Equation 3 minus 2 into a, so that is minus 2 into a is 1. Minus b is minus of b is minus 2, so it becomes plus 2, plus c is minus 2. So this is minus 2, this is plus 2, this will cancel out, and c becomes minus 2. So I have got all those values, a, 1, b minus 2, c minus 2. So a is 1, b is minus 2, and c is also minus 2. Okay. So our original equation was this one. So S dimension is equal to, this is dimensionless, so only you have to put the power of ABC. A I got as 1, I'll put 1 here. B is minus 2, so B, the power of B is B, which is minus 2, so I'll put minus 2 here, and also this is minus 2. So that means it is e to the power 1, that means e, v raised to power minus 2, t raised to power minus 2. So this is the dimension for surface tension. if I see the option, then you can see that the option number 1, e b to the power minus 2, t to the minus 2. So this is the right answer to this question. Okay, thank you.